This is video number 4 on the 6-cycle oddball, and we're going to do the flywheel. This is the slug. I've faced both sides of it. I bought 2 slugs, and they were half an inch long, and I paid for 2 inches actually, but they were like $22 a piece, and they did the cutting. I imagine you could buy one piece at 1 inch for the same price, and if you could cut it in half accurately, you'd save some money, but I can't do that. If I cut this far through, it's going to come off a little bit. Anyway, there's the slug, and I faced it, and I just drilled a rough hole in it. I'm going to use this outside jaws to grab it. And the first thing I'm going to do is do the recess. And that's a 1/4 inch deep, and it's a 45-degree angle on here, and I have to put a mark on here to see how wide it is, so I'm going to put some bluing on it. So on the plan here, it shows 15/32, which is probably was a ½ inch when they went from the outside, because I have to turn the outside to finish it. And so I'm just going to go in a ½ inch and make a mark. I'm sure this is not critical at all, just to put the relief in there. It's more for looks than anything. And then I'll mark it with the tool. Okay, there's my mark. And it's exactly, well, it's just a hair over, so I can take the mark off of there and I'll have a ½ inch. So we got to change the tool. So what I'm going to use is a tool with the rounded on both ends, so I can cut in both directions. Okay, there's 0. I come over here. I'm going to set up my stop for a 1/4 inch deep. So 1, 250. Okay. So now I can cut right into the stop, and I've got it. The center is supposed to be 3/4 in diameter. You got to measure that. This right now is over 1 inch. Now, this is the outside of the rim, and it's a 45-degree angle into there, so this has to be approximately, it's almost a ½ inch difference here. So I'm not going to cut it all the way in, all the way out to that line yet. I'm going to go right to about there. I'm not using a lot of cutting oil here because it makes too much smoke. You can't see anything. But, I do have to have some on there. Okay, that's a 1/4 inch deep. I'm going to change the tool and do the chamfer. Then I can finish that out to size. Now I better check the tool height again, because that's good. Now what I'm going to do is start putting this 45-degree angle on here, and that will let me know where this has to end. I'm not going all the way to the bottom here, I'm just eyeballing it. I just got to work my way out to that line. Same here. We're almost out to the line. And when we get out there, I'll measure it. It's measuring about 570, which just is still a little over, so I'm going to go right out to the line. Just about right. We've got about 30 more. Let's go 15. I'm going a little slower on this because this will be the finished cut. For now, it's fairly smooth. Now I got to go back to the other tool and finish the face of it off. Now I'm going to finish off the bottom of it. Jim was asking me how I could see through the chips. I don't see through the chips. When I'm cutting on this side, I'm actually looking over here to see where it's cutting. And it's easier than trying to see through the chips. So I'm just going to face this off nice, smooth. I'm just going to change that tool angle a little bit. Move the tool out further. You just want to get all the tool marks out of there, basically. Shine it up a little bit. I don't want to take too much time on this because it's Jim's time is very valuable here. So I can finish that up later. That looks pretty good. Okay, that's it for the turning. Now what I got to do is get the whole board in true while it's in the same setup. Now what I have there is a roughed hole that's 5/16. It'll go all the way through, no problem. I put a stop here so I can't run into the vise. Bring it up so it touches. I put this on power feed. I'm going to measure that. I want a 3/8 reamed hole, and I'm going to ream that 1/1000th under, because the only one I have is a 1/1000th under, so I can do a shrink fit on the the shaft. I'm going to take another light cut. Let's measure that. We got plenty of meat left. We can take off another 5. I'm going to leave about 5 thousandths to take out with the reamer. Take another 5 and run it through twice. I'm just going to run that through a second time without changing anything and see what I come up with. It should be pretty close now. So let's measure that. It took off quite a bit. It's now 8. It needs another 8 thousandths taken out. So I'm going to run that through again. Make sure that this is right. Without adjusting anything. You should just cut just a hair now. That's the spring of the tool. And quite a bit on this one. As you can see, it took off quite a bit. That may be close enough. No, it's still 2 thousandths. I'm going to take off 1 thousandth by using the cross slide, the compound, just to try to take out 1. That's 71, so that's 371. So there's basically 3 thousandths to take out with the reamer. So that should be 1 under. It seems to measure just about exactly 1 under. So now we turn the second flywheel, and what I've got to do is get a pin that will drop through there that's 1 under to keep those perfectly aligned, and then we'll put it in the miller and we'll move over here and drill that second hole. So I don't have a plug gauge set up to a 1/2 inch. I wish I did. So I'm going to have to turn a pin that's 1 thousandth under, and I'm going to use the collet chuck for that.
Make sure it's in the right position there. Put the handle back. We're going to get a 3/8 collet.
So that pin has got to be a little over 1 inch. Let's see. See how true that will run. This collar chuck is probably 1,000th out, unless I tweak it every time I put it in there, but I can probably turn a pin that's pretty close with that without tweaking it. What I'll do is I'll use the flywheel to gauge it and see when I can get it in there. Take a couple of light cuts off of here and then sand it. Sand it smooth. Just until it just slips in there. So that's actually measuring a little over 1 under. So let's see how that fits. It won't go, yeah, I guess it does go in there. Yeah, it does, just barely fits. I'm gonna make that a little bit looser by sanding it.
I don't want it to get stuck in there. I have to dry it out with a punch. Okay, that should work.
So I got that pin in there. It's a little tight, but it's a nice fit. Well, that'll keep them in perfect position for drilling the other hole. Okay, clamp that down. You got it on. So what I forgot was to put a center point in this so that I can line it up in the milling machine. So I got to put it back in here. Just hit that with the spotting drill so I have a center. That's all it takes. It's just a tiny spot. Just going to cinch that down fairly tight. Doesn't have to be anything super. I'm just going to drill a hole in it. Now we got to put a center in there. Now, if that was off a couple of thousandths or 3 or 4 thousand, it doesn't matter because it's the stroke of the engine. So your piston will not go up 2 thousandths or 3 thousandths. It doesn't matter. So this just has to be fairly close. Okay, the print says that that's 13/16 off center. So we got to change that to decimals. Zero this out. You come over here, Jim. I'm going to zero this out. I'm going to go over 8/12. 8/12. And lock the table. So that should be the center point for the hole. 8/12, double check myself. 13, spot that. And that's just a reamed hole. You don't have to bore it. Start out with an 1/8" hole. This is a brand new drill, so it should cut pretty good. I'm going to step up to a 3/16. Into a 1/4 inch. Now we're going to go to probably a letter drill. Get almost to 5/16. Okay, I'm stepping up now to a letter N drill, which is 302 thousandths, which will mean there'll be 10 thousandths to ream out of there. Okay, I'm doing a 1 under reamer, and then I'll go to a 5/16 reamer, just to save my reamers.
Gotta be really slow.
Now I'm going to ream it to 5/16.
Well, that's just barely taking a tiny, tiny bit out of there. A thousandth of an inch, actually. Okay.
That should do it. Let's take it out of there and see how it looks. So the next thing we got to do is turn the outside perimeter, and to do that, I needed this hole here to drive the piece, and I'm going to put this in the chuck, and then I put a center pin in there and turn the center pin so it's running true, and then we'll bolt this on there, and it should be good. I'm going to go back to the 3-jaw chuck with the outside jaws. So this is just a slug that I made up probably, maybe for this engine, I don't know, but I've used it a few times. And what it has is a center hole, and if I have a 1 on it here, so it lines up with number 1, so it goes back in there pretty true. Just in the exact same position that I put the holes in there with. Now, let's see. And then I have some slugs that I can turn afterwards, so this is perfectly concentric. Oh, here's one. That's the slug, and it screws in here, but here's one that I've used before. Let me measure that. Yeah, good. This is over 5/16, so I can turn this one down again and use it, and I won't have to thread the other end. It'll save me a step. So we'll screw this in there. Make sure it's tight. I got a pair of pliers here. It doesn't matter, I'm marking that up, but that's going to be turned anyway. So what I'm going to do now is turn that so the flywheel just slips on there, and that'll center it. I hope that's thick enough. Let's see. Oh yeah, that's a little over 1/2 inch. I might have to use a washer on it, but that's okay. I can do that. That's a little too long, actually. I got to get that down to 3/8. Right now it's 450, so it's got to go down almost 100 thousandths. Let's take a cut of 20. So now I got to go down 10, 20, another 30. So I'll go down. Let's take a cut of 10. That'll get. So that's going to have to be 1 under 375. So I'm going to have to go to the mic. We want to get this pretty accurate. Right now that's 15 over. Let's take 4. It's now 9 over. Start using the compound here. 1, 2, 3, 4, 5 thousandths. That should... Now it's 4 over. 2, 3. I'm going to sneak up on that. That's right on. So it has to be 1,000th under to fit the flywheel. So let's try the flywheel first. See if it goes on there. No, it just barely starts. So we got to go a hair more. I'm going to try a 1/2 thousandth. Not quite yet. We go another 1/2 thou. There it is. 0 clearance. So now I'm going to put a little chamfer on this end so I know it's up tight. So this is going to be the drive screw. It'll drive it so it won't slip. I got a couple of washers on there. And now I got to get a nut on here with a washer. And that'll be it. Now you can do this with a face plate, but what you have to do is you have to block this out because you got to cut all the way across it. So doing it this way is a little easier for me, and because my face plate is huge anyway, so this is a lot easier to use in the 3-jaw. So let's take a cut on that and see how it cuts on the outside. It's going to be a little rough at first. So I think I will use a carbide bit. Okay, that's the final cut on this one. So what I'm going to do now is I'm going to zero this out so I can come back to the same exact spot on the second one. But first I'm going to polish this one off before I take it out of there. I'll try a little sandpaper. It looks pretty nice. I'm happy with that. So slow the way down. I'm going to take a light cut for the last cut, save myself some filing this time. On the second one, I took a very, very light cut and at a very low speed, and I got a much better finish. So I think what you have to really turn the speed way down to get that final cut. That'll be less filing now. good. Here's the two flywheels finished. And the next thing we got to do is put the shaft into it. And for that, I'm going to try a shrink fit. This is an experiment. I don't know if it's going to work. But we're going to turn this on, put it on high, set one of these on here, and heat it way up, and then try to put the pin in it. These are the two crankshaft pins, and they won't quite go in there when it's cold. But hopefully when I heat that up, I can drive that in there. When it cools, it'll be a nice shrink fit. So this is about as hot as it's going to get. The thing shut itself off, the safety switch shut off. So what I'm going to do is take that off there with pliers, put it up here, and then I'm going to heat it a little more with the torch. Like I said, this is an experiment. Does that go all the way in? No. You put it in the vise here and see if I can shove it in. Let's see. That's in there all the way. It's never going to come out of there. The first one was too tight. So what I've done is I've taken 1/4 thousandth off of this one. So it should go in there a little easier. And we'll try that one. And I have to heat it up with the torch more. I'm going to see if they'll just tap in there a little bit. Oh, look at that. That fell in there. That's all the way in. So that's 1/2 thousandth fit. So if you get it hot enough, it'll just drop right in there. I'm going to see if this got bent when I drove it in there, because that went in pretty tight. Just put that in this chuck, turn it on. Well, that's pretty good. I don't see any real bend in that. Let's check the other one. The other one went in easy, so it should be perfect. So that's as true as the chuck. That's pretty good. I think we got it good. So the secret is to get this hot enough, and that pin will drop right in there, even though it's 1/1000th shrink fit. But you got to get this thing really hot. You saw that just fell right in there. And I took a punch and a hammer and tried to tap it out, and boy, it won't come out of there. It's tight. So the next thing we got to do is put in the 2 balance holes. Now I don't actually do that. I don't like to see those holes on the outside, so I do it on the inside. And I'll show you how I do it, but you can just drill 2 7/16 holes through it, and that's the balancing. So I'm gonna put that here in the rotary table. And I've got to line it up with center. Line it up with the center. Lock that in. Okay. Now I'm going to come back to this hole and get that sort of on center. Tighten this up. So they say to move out, let me get my glasses on here. Seven on a diameter of 1.2 5 30 seconds. 5 30 seconds. That would be 5 30 seconds. 156. Actually, I can use this and use the 30 seconds. 5 30 seconds. That would be right about here. But I'm going to move that out a little more because I don't want to be near that hole. And I'm going to do a little arc right across there. So I'm going to move it out a little further than that. And we'll crank that out. And we're going to go out about here. Now, when I move it out, it actually makes it more effective because the less weight it is on the outside, it's hard to explain, the less inertia. So by moving it out, I could actually make a little bit less, but I'm going to leave it the same because I'm going to add a connecting rod bearing on this, and that's going to make it a little heavier. So I'm going to do an arc of 20 degrees. I measured the other one. So the first hole will be here. And I'm going to start off with a 5/16 drill here. So this is only a 1/4 inch thick, so I certainly don't want to go through it. So I'm going to go in about 150 thousandths with that drill. And then I'm going to use an end mill to finish it with. So now what I'm going to do is put an end mill in here, a 3/8 end mill, and connect those. So now I've got my end mill in there, and I'm going to try to come down to the same depth, 150, but I'm not going to do that all at once. So there's that. Now, what I'm going to do now is I'm going to go back a little bit further on it to make it a little wider, because it was a 7/16 hole, and I'm trying to take out about the same amount of material as they did. Just a little bit shy. I'm only about 15 shy, but I put it back in there and do that 15 thousandths. There it is. I should finish it. The finished slot. And this is a tiny bit more than if you drilled 2 holes. And I would say about 30% more. And of course, I can do that to both flywheels. And because it's further out, it's more effective. That's it for the flywheel. Now we got to make this piece that is the connecting rod journal. Whoops, have that right side up. And that's made out of 3/8 drill rod. And I've already put the piece in the chuck. And they turned this between centers, but I don't believe that's necessary. The 3 motors that I built before, I did not do that because I have a fairly accurate lathe. And I'm going to check my run out on this and just do it in the chuck. And I could do it in the collet closer, but most people don't have them. So I'm just going to show you how to just do it in the chuck. I'm going to put a dial indicator on this and see what the run out is in that chuck. Yeah, that's less than 1. I can see it there. It's about, that's going to be good enough. So first thing we're going to do is face it off. We're going to move it down. Let's see what we got here. We're going to go down a little over a 1/2 inch. 2, 3, 4, 5, 31. That should be it right there. That's what I did, 531. So now I'm going to turn this so it just fits in this hole. And that is supposed to be 5/16. We're just going to double check it. Make sure we got it. Yep, that's 5/16 right on the money. And I wish I had a set of plug gauges for that, but I don't. And I'm going to switch to the micrometer. A little better reading here. So I've still got to go 6 thousandths. So I'm going to start using the compound that's more accurate. 1, 2, 3 thousandths. That only took off 2. So I've got 2.5 to go. So we're going to go just a little over 1 and check it again. So we get 1 thousandth to go. And then we'll check it with the part. So I'm only going to go halfway down here. That's the threaded part. Get that out of the way. So I've got to take off less than a half a thou on that. So I'm going to do that with sandpaper. Boy, that's a perfect fit right there. Okay, so what I got is a cutoff tool that's ground off a little bit so that I can only take out 40 thousandths there. And I'm just going to make a groove so that the piece will seat properly. Now this should slide all the way back, which it does. Perfect, nice tight fit. I like that. Next thing I'm going to do is put this in here, and I'm going to move it out a 1/4 inch and make another relief cut. There's 1, 2, 50 right there, and that's where my thread will end. Now to make it easier to thread, I'm just going to take a couple of thousandths off of the threaded part. Why doesn't that go down? Okay. Okay. Use some threading oil from Tap Magic. Put that on there. And somewhere I have a die. Now, what I'm putting on there is a 5/16 40 thread. They call for a 5/16 32, I think, no, 24 thread, which I think is a little coarse. And I have these fine thread taps and dies, so I use them. But you can use any thread you want. turn that off. Put it back and forward. I'm going to turn the die around and run it on backwards so I can finish the thread all the way to the end. And there it is. Now they used a hex nut on here, but I make my own nut that I like. Looks a little bit more professional. Thing. This is the nut I'm going to do, and you can see that already has the thread in it. Got a little burr on it there, so that should go right on there now. Yep. As you can see, if I put that on there like this, and I've made a special wrench to do that. This is things you don't have to do. You can use a regular nut and a regular thread if you want. I just think this looks nice. Yeah, that's tight. It's just flush, which is good. Now we'll turn it around and do the other side. You're going to take this out of there and cut it off to length. I'm going to take it over the saw and saw it off a little long, a little strong. So I can put it in right to about here. And then what I'm going to do is check it up with the dial indicator again, right there. Check the dial indicator so I get that fairly good, and that should be running almost perfect. That's pretty good. Let me put it up on 0 here. It's less than 1,000th run out. That's pretty good. So now what I'm going to do is I'm going to take this out and put some bluing on it and mark that, because this is what gives the flywheel their width, and if you don't get that dimension right, you might have a problem putting the flywheels in the engine. It might be too wide. So that's 0.438 is I'm going to put it in this to avoid any mistakes by my mathematics, and you see that that's down there. I'm going to come down here to 0, 1 inch 53 thousandths. Mark that all the way around. Oh. So now if I come up to that line with that first cut, that thing will be perfect width. Okay. Nope. Don't want that speed run. And that's pretty good. It's within a thou. My first cut, I'm just going to bring it right up to that line. now I'll just finish this the same way I did. So there's the part. So now we can put it together and see how we did. I put the 2 nuts on it here. This is the tight one. I don't have any way to show it turning yet until we put the bearings in the engine sides, but we can do that next week. And that's what holds the thing aligned. But there it is, all together. And they should run pretty true once we put them in the bearings. We'll tighten those at the very end. We'll put that in there, put all this together, and then tighten the last nut, and that will align it, because this should be perfectly aligned because you're grabbing both of these. But there it is. Next week we'll start on the cylinder. This is the slug for the cylinder, and what I'm going to do is just rough bore it and size it so it'll be a little shorter time. So, thank you very much for watching. If you liked what you saw, please give us a thumbs up. And if you've subscribed to our channel, that helps us a lot. Thank you very much.